Hello and welcome to another episode of NextGen AI. Again, I am your host, as usual, dsingley with MAPSYS. And wow, this is like what, the third episode now that I've stolen and captured a real-life data scientist. This is Daneyand from QLX. Daniel, say hi.
Hello, everyone.
Today we have another interesting video for you. And this is what I'm going to lovingly refer to as the Daniel Show, because again, he's the real data scientist, and I'm just, I'm just your host, right? So I'm just the guy here to help you understand power and programming and architectures and that kind of stuff. So we're gonna let Daniel loose on some of these cool features, most notably large model support with IBM's Watson Machine Learning Community Edition framework package. Hey, Daniel, I got it right that time. I didn't say Power AI, so that's a plus. That's a small win every day, folks. So listen, Swati, why don't you come over here? We're going to take a look at how to enable large model support rather, on these particular frameworks. Okay, Daniel, I'm going to put it right here and let you drive, my friend. What are the three? Did we already say that? I think we did.
No, we haven't.
We haven't. All right.
Okay.
What are the three deep learning frameworks we're going to enable large model support on?
PyTorch, Caffe, and TensorFlow.
Fantastic.
So what's great about how LMS has been implemented is that it's very straightforward to use it on your already existing models. So let's say you have a DDQN model that gets trained by looking at pixel inputs, like OpenAI, GIMS, Atari, environment, right? And you want to up the resolution of your inputs, even though the Atari one might not be a model that will improve that much with much more resolution, but it's a good example for starters. You don't have to redo your coding. For example, here for PyTorch, all you will need to do is just run this command to enable LMS on PyTorch, right here, torch.cuda.set enable LMS true, right, prior to the model creation, okay, and then you can tune the limit LMS to define the sublimit in bytes of GPU memory allocated for the tensors, and the cuda.set size LMS to define the minimum tensor size in bytes that is eligible for LMS swapping. And by doing this and training your model normally as you will normally do, you are able to use large model support.
Fantastic. So this is the Watson Machine Learning Community Edition documentation website. So all this can be easily found for anyone developing on the WML framework package.
That's right.
Great. So that was PyTorch. So what else are we going to talk about here? I think we wanted to look at
TensorFlow.
Yeah, TensorFlow, and is that over here? There it is.
All right. So for TensorFlow or large model support, something that's amazing is that they took into consideration that you might be doing session-based training, estimator-based training, or keras-based training. So whether you like using your keras syntax, whether you're using estimators or a session-based training, you are good to go. All you need to do is add a few lines of code, probably modify another, and that should be it. For session-based training, all you need to do is import LMS from the library, and then instantiate your LMS object and then run it, and you embed that into the session automatically, and it does all the work for you.
Outstanding.
Estimator-based training, same story. Just import it, instantiate, and then add the LMS object into estimator's hook list, and you will be good to go. And with keras-based training, as simple as before, import, instantiate, and then add it to your generator, to your fit generator, and that's it. You just pass it as a parameter on the keras fit or fit generator function, and you'll be good to go.
Boy, that seems almost way too simple.
Yeah, it
really
is. It is, and it works. So that's amazing.
It's not going to throw anyone that's reading or watching these videos into fits that they're going to have to refactor their code with all this very, very hard to maintain stuff. It's very easy.
Exactly.
Sure. Okay, let's take a look at the Caffe one. I believe, in my opinion, that seems to be the simplest one of them all. So how do we do that?
On Caffe, all you need to do is just, after, of course, installing the library and having your code ready, all you need to do is just change the command that you're passing, and you pass a tag to the command right here. Okay, so you have your cafe train command, right? And then you add -lms size threshold, and then -lms exclude. So on this first one, you add LMS, and then you tune it just as we did in PyTorch, in a very similar fashion. Okay, and that's about it. No need to change anything else. Just the command.
So it's just on the command line. That's it. There's nothing, no code you're even really writing. It's just how you actually run the model.
Exactly.
Or train the model rather. Amazing. Wow. Okay. Well, Daniel, in your future projects, what do you think about LMS and how you're going to use it?
So we're trying to leverage LMS as a way to use higher resolution on our image classification algorithms, where we understand that just increasing resolution by itself doesn't really improve accuracy, and that's actually not beneficial in certain models. There are certain specific applications where you need to detect very small objects, or you need to detect very specific features, and in those cases, then you need to handle higher resolution images. Of course, noise and other problems are part of that, but it is a necessity to be able to improve that accuracy, to have this higher resolution images as inputs, and this is definitely a use case for large model support that we wouldn't be able to achieve on another platform.
Wow, that's great. That's good to hear. That's good news for the IBM AC922 and for the power platform of these NVIDIA GPUs for sure. So it's a real plus going forward with this platform. So you heard it here first, folks, from an actual, real, live, captured, albeit, data scientist. So Daniel, thank you so much for that. Well, Daniel, thanks for that explanation. I think that really is going to help a lot of people understand that this, again, is not a scary technology, and it's not a particularly hard technology.
Right.
So great. So, well, folks, you'll see Daniel one more time here, at least in person, in our next video. And we really thank you for watching, and we'll see you all soon.
See you all soon. Thank you.